Looking at number 1 here, it says rewrite the expression in a simpler form using use substitution. So what we're going to do here is we're going to notice that this main function here is cosine, and then we're also going to notice that this x will come from the chain rule when we check using the derivative. So let's go ahead and let u equal 16 minus x squared. We know from past experience we will end up needing the differential of this. So du is negative 2x dx. Also, since this is a definite integral, this 0 and 4 are what we need to plug in for x, but we're changing everything over to u. So we have to find what those are in terms of u. So what we're going to do is we're going to let x equal 4, and we're going to put that in for x. And so u will equal 16 minus 4 squared, which is 0. And then we're going to let x equal 0. And so u will equal 16 minus 0 squared, which is 16. And so when we do our u substitution, this is going to be going from 16 to 0. And we'll have cosine. So here's our main function, cosine of 16 minus x squared. Well, now this is just going to be cosine of u. And then we want to substitute for this dx. Well, we have an x dx. And so I'm going to solve for x dx right here by multiplying both sides by negative 1/2. The negative 2 and then negative 1/2 cancel, so we can take out the x dx, and we can put in negative 1/2 du. Usually we put the constant out here, negative 1/2 du, and we also have this 4 still here, so that 4 needs to go along. And then we can simplify, we can bring the 4 outside, so this is going to be negative 2 cosine of u du. I didn't put the limits of integration here, so it is from 16 to 0. All right, the next one, find the minimum and maximum of this function on the interval negative 10 to 7. So this is a closed interval. We do know that this graph looks something like this. It's negative cubed, so it looks something like that. So what we're going to do is we're going to find this minimum and maximum point by taking the derivative. And so that's negative x squared minus 5x plus 14, setting it equal to 0, because we want to find when the slopes of the tangent line are 0. So we got negative x squared minus 5x plus 14. We'll divide everything by negative 1. And so that will give 0 equals x squared plus 5x minus 14. And then we factor, and we get x plus 7 times x minus 2, which means our points that we're concerned with here, our critical numbers, are x equals negative 7 and 2. From our knowledge of the graph, we know that this x value here is negative 7, and this one is is 2. So then what we want to do is we want to take our function, and we want to plug in each of the values. We want to plug in the relative min, the relative max, and the endpoints and find which one is the largest and smallest. So let's start with the furthest left, so f of negative 10. Then we'll do f of negative 7, f of 2, and f of 7. Plug those in, find out which is the maximum, which one's the minimum. And I'm going to stop there. All right, next one. Find the inverse of pi over 2 when f of x equals arc sine of x over 2. So we want to take the derivative, the inverse, not the derivative, inverse. And so what we do is we switch x and y. So this is our normal y. So we want to say x equals arc sine or inverse sine of y over 2. So what we'll do is we'll take the sine of both sides. So take the sine of both sides, and we get sine of x equals y over 2. Multiply both sides by 2, and we get y equals 2 times the sine of pi over 2. We have our sine function. Here's pi over 2, so pi over 2 is 1. So we have 2 times 1, which is just 2. All right, number 4. Number 4, we want to integrate. We could use u substitution, or we could use guess and check. So let's go ahead and guess. Well, first of all, we might want to rewrite this as 3 sine of 2x times 6 plus cosine of 2x to the negative third power. And so think about integrating. Here's our main function. This will go up 1. So we have 6 plus cosine of 2x to the negative 2. And we bring the reciprocal out front. So negative 1/2 plus c. That's our guess. Let's check it. So the derivative of that, the negative 2 comes out front, which cancels with the negative 1/2. So we have 6 plus cosine of 2x to the negative 3. And then we're going to multiply by the derivative of what's inside. The derivative of 6 is 0. The derivative of cosine is negative sine of 2x. And the derivative of 2x is 2. And so let's compare this to what we have. We do have the denominator there. We don't have a negative, and we have a 2, but we don't have this 3 here. And so we need to cancel out the 2. So our answer, well, let's write some things in here. So this was our guess. We want to cancel this 2, so we need a 1/2. We need to cancel the negative, so we need a negative. We need the 3, so we're going to multiply by 3. And I think that should do it. So it looks like what we end up here, we'll put our answer at the bottom in our simplified form. This will be negative 3 over 4, 6 plus cosine of 2x to the negative 2 plus c.